So what we did last time, if you remember, we defined what we call differentials, and then we used it to estimate values of functions and also to estimate errors. Let me just remind you quickly of the meaning of differentials and then the types of error we discuss at the end of the class. We said if we have a graph like this, we have a graph y equal to f of x. This is y equal to f of x. Assuming we have a point here A, then we said always we can have a tangent line approximation for the function if we are close to A. If we are close to A. Now, this linear approximation, if you remember, we said L of x, we call it linearization of the function. This is y equal to f of x, okay? And this is what we have, the x-axis, the y-axis, and this is our L of x. It is just f of a plus f prime of a multiplied by x minus a. And you should understand that this represents the equation of the tangent line at the point A. طيب, this is called linearization. What is the differential of the function? What is the differential of the function at that point? We said if we move a distance from A to a certain point, A plus delta X, let's call it. So if we move a distance here up to A plus delta X, then this delta X, or you can say it is A plus dx, the same. Then you have a real increment, an exact increment that can be found by using the function itself. And that is called delta y, the increment in y, the actual increment in y. By definition, it is the difference between the image at x plus delta x and the image at x. In this case, it is a plus delta x minus f of a because we are evaluating at a. Otherwise, it is in general f of x plus delta x minus f of a. So if you allow me, I can write it in general like x plus delta x minus f of x. There is an approximation for this. We call it dy. Now, what is dy? This one, look, this difference here, which is L of x plus delta x minus L of x. يعني بمعنى آخر, we are approximating the function by L. So we are approximating the difference in the increment of y by using L. We call it the differential. This is exactly equal to f prime of x multiplied by dx. This is called the differential of the function f of x. Okay, we can use it always to estimate the delta y quantity. And we said by using this argument here, we can measure the error involved in certain measurements by the following three types of errors. We can have the exact error. We call it delta y. Delta y is the exact error اللي هو معرف بالشكل التالي f of x plus delta x minus f of x. If we make an error in the x measurement by delta x, the corresponding error will be in y is called delta y. This is called the maximum error or the exact error. This can be approximately be found by dy اللي هو عبارة عن شنو f prime of x dx. We have the relative error that is delta y over y, and this is approximately equal to dy over y. So it is approximately equal to f prime of x dx over y. Okay, so that is called the relative error. If I multiply this one by 100, delta y over y multiplied by 100, I change it to percentage what? Percentage error. Any point which is not clear for you among these points, I will write finally the relationship between the two formulas, then I will start the solution of this exercise. لاحظنا قلنا ال L of x اللي هي linear approximation يكتب بالشكل التالي f of a plus f prime of a times x minus a. This can be rewritten if we allow x minus a or يعني to be dx, then x will be a plus dx here is approximately equal to f of a. I can write this one in terms of differential as dy evaluated at x equal to a. هذه النقاط الأساسية اللي ناقشناها في الدرس هذا. Any point that is not clear for you, please, before I go to the exercise? Go ahead. So it seems everything is clear, is it? Okay, if everything is clear, can you write number 1 for me in the chat so I can feel that you are with me? Yes, write number 1 in the chat. So طيب ممتاز. So let us now do another exercise about what we call measurement of error by using differentials. لاحظ السؤال شو يقول هنا. يقول we have a cube. The edge of a cube was found to be 30 centimeter with a possible error in the measurement of 0.1 centimeter. So we are trying to construct a cube. We are trying to construct a cube whose side length is, he said what, how much? 30 centimeter. So we are trying to cut it like this. This is a cube, something like this. So let me just try to draw it for you. This is what we have. We don't need to sketch the graph, by the way. We do not need to sketch the graph, but this is what we are trying to do. We have a cube like this, whose side length is equal to what? According to the question, it's supposed to be, this measurement, supposed to be 30 centimeter. But of course, as we said last time, you will never cut it to be 30 centimeter. So we will let it to be equal to, I will call this one X. So this is, let the side to be X, let the length of the side is equal to of the side of the cube to be equal to X. طيب. If I measure it, this X is supposed to be 30, but I have an error of how much he said? 0.1. So dx is equal to 0.1. This is the error involved in the measurement of the side x. He said use differentials to estimate. ليش قال use differentials to estimate? Because if you need the reality, you need to find delta y or delta v or whatever in the volume. But he said, okay, you can use differentials to estimate the maximum error, the relative error, and the percentage error of these two things: the volume of the cube and the surface area of the cube. So use differentials to find the maximum possible error, relative error, and percentage error for these two quantities. طيب. السؤال الأول. Part A, we are talking about the volume. Once we talk about the volume, who can tell me what is the volume of the cube in terms of x? What is V of x? Yes. يوم خميس نبغى نشغلكم شوي على اساس ما تناموا يعني. V of x, what is the volume of a cube with length is equal to x? Yes. X to the power 3x cubed. So
Yes.
what will be the maximum error? Let's call it part 1. This is part 1. Maximum error in the measurement. Maximum error is delta V, which is what? Which is given by dV approximately. The maximum error approximately, let me call it delta V first. This is delta V, which is approximately equal to dV. Now, what is dV? dV is 3x squared multiplied by dx. Now, what will be our maximum error in this exercise? dV will be equal to 3 times. Now, what is x? X is 30. So it is 30 squared multiplied by dx. He gave us dx to be 0.1. Jamil, what is 30 squared now? 30 squared is 900. صحيح? 900 by 3, that is 2,700 multiplied by 0.1, that is 270 centimeter cubed. If it is given in centimeter. Yeah, it is in centimeter. هذا يسمى الماكسيمم error. Maximum errors is 270 centimeter cubed. The second part, he said, find the relative error. What is the relative error in the measurement of this volume if we use this kind of errors we have in the measurement of the side x? طبعا by the definition, the relative error is equal to, if you like, it is delta V over V. Delta V over V. So it will be dV over V approximately is equal to dV over V, which is equal to, الآن you need to substitute by dV in the numerator. dV is 3, okay. dv is 3 times x squared multiplied by dx. هذا dv divided by v. v is equal to what? v is equal to x cubed. فراح تلاحظوا يا شباب الجواب شو يساوي؟ This will be equal to what? 3 times what? dx over x. ولهذا بعض الأحيان في الامتحان ما يعطيني الاكس، ما يعطيني اللي هو الاكس ولا يعطيني الايرور في الاكس، يعطيني الريلاتيف ايرور ان اكس ويقول لي find the relative error in the volume. فنلاحظ الآن شو العلاقة بين الريلاتيف ايرور on the side x and the relative error in the volume. It will be what? واضحة الآن من الشكل المعطى عندكم. شو الجواب؟ 3 times the relative error. But anyhow, we have everything here. So it is 3 times dx, that is 0.1, divided by x, that is 30. So that is equal to 0.1 over 10, if you like, and that is 0.01. العلاقة بين the relative error of the volume and the relative error in the side x, it is 3 times. Number 3. He said find the percentage error. What is the percentage error in the volume? It is the relative error dv over v multiplied by 100, and the answer will be in percent. يعني 0.01 times 100, that is what? That is 1%. Okay. So this is the first part. Why don't you think about the second one? Let's look for the second one. He said do the same for the surface area. I will give you 2 minutes to answer this question. Do it, please. Do the maximum error, relative error, and the percentage error for what? For the surface area of the cube. So anybody can volunteer to give me at least the first one, the formula of the surface area? Yes.
Yes. 6a squared.
Okay, let me just add one more page. I guess we need to. This is not responding. The one note. Okay. Yeah, it is working now. طيب. So let us start first at least to find the surface area formula.
6x squared.
لاحظوا يا شباب هنا في نوعين من المسائل. تارة يقول cubed ومثل ما قال زميلكم الآن السيرفيس area S عبارة عن شنو؟ 6 times the area of one face of the cube. So it is 6x squared. وتارة يعبر عن هذا الموضوع يقول box or rectangular box. ايش معنى rectangular box؟ يعني عندي شكل زي كذا مو متساوي الابعاد. Something like this. This is called rectangular box. فلو فرضنا مثلا هذه x وهذه y وهذه z. من يقول لي what is the surface area of this؟
We multiply all of them. X times y times z.
That is the volume. Yes, x times y times z. That is the volume. I'm talking about the surface area.
X plus y.
بالشكل هذا شو يصير؟
To be 2x times y.
أيوة 2 times x times y.
Yeah, that's for the top and
Yes, plus x times
z
z plus
side
y times z.
Z.
احسنت. هذا يسمى السيرفيس اريا. عندنا 3 types of faces. x times z هذا واحد، والجهه الاخرى z times y هذا الشكل هنا، والجهه الاخرى، وعندك التوب and the bottom x times y. فنلاحظ السؤال، نقرا السؤال بشكل جيد. Is it rectangular box or a cube? A cube يعني all sides are the same, so we need to do only 6x square. جميل. الان زميلكم قال هذه هي الاس. What is the maximum error? Maximum error. What is the maximum error? Approximately equal to what using differential? It is ds. What is ds? It is 12 times x multiplied by dx. So the final answer will be 12 by 30. That is 360. 360 multiplied by 0.1, which is, sorry, this is equal to what? This is 0.1. So the answer will be what? 36, which is 36. Of course, this will be in centimeter squared. Let me take it a little bit up so I can write the units here. Okay, this is maximum error equal to this. This is in what? In centimeter squared, because we are talking about area. طيب, what is the relative error? And what is the relationship between the relative error in the side x and the surface area? What is the relative error? Relative error approximately equal to ds divided by s. ds, s is 6x squared, so that is 12x dx. Divided by s, that is 6x squared. If you calculate carefully, this will give you 2 times dx over x. يعني the relative error in the surface area is twice the relative error in what? Sorry. Yeah, the relative error in the surface area is twice the relative error in the measurement of the side of the cube. طبعا الجواب هنا راح يكون 2 times dx, that is 0.1 divided by x, which is equal to what? Which is equal to 30. You can calculate this one and find the answer. It will be 0.1 over 15. Can you do it, please, and give me the answer for this? I will do also myself. I will calculate this and find the answer.
150.
Okay, good. That is the final answer. So the answer is how much? 0.1 over 15 is the answer.
1 over 150.
Yeah, I need the answer in decimal, so it will be around
0.00667.
something like this, or let us approximate it to be 0.067. طبعا that is the relative error. Finally, what is the percentage error? Percentage error will be equal to 0.0067 times 100, and that is in percent, and this will be equal to 0.67%. So yes, this is what we have for section 3.10. We have the idea of linear approximation. We have the idea of what we call differentials and the use of each one of them. We use the linear approximation to approximate functions by using linear functions, and we use differentials to estimate types of error in measuring certain kind of, let us say, geometry or any, real life problems. So if you have any question in between, or I will move to a very nice section called hyperbolic functions. طيب. Let us conclude this chapter, this lengthy chapter, 11 sections we have. Chapter 3.11. Hyperbolic functions. Hyperbolic functions. We have 6 new functions today we'll introduce. These are called the hyperbolic sine function, hyperbolic cosine, hyperbolic tangent, so on, cosecant, secant, cotangent. 2 things here of interest. يعني the first one, why they call these functions hyperbolic? 1. 2. Why sine, cosine, tangent with h here? Hyperbolic sine, hyperbolic cosine, hyperbolic tangent. Inshallah, we'll answer these questions while explaining while we are explaining the section itself. يعني during the explanation, it will appear for you why they call them hyperbolic sine, hyperbolic cosine, and why hyperbolic word is appearing here. Okay, I will add one more point about these functions. These functions are very important functions in solving differential equations. The hyperbolic sine, cosine, tangent, especially for partial differential equations in certain types of domains. These are very important types of functions we need to study. What is now the definition of these functions? How to evaluate them? What is the domain and the range of each function? And then what are the identities related to these functions? And finally, how to find the derivative of these functions. These are a couple of points we need to illustrate and we need to discuss together, inshallah, in this section. So first one, what is the definition of the hyperbolic sine function? You remember in Math 002, we studied the exponential function, and we said we have two types of exponential functions, either decreasing or increasing. One special function here is called the natural logarithm, the natural exponential function, a function coming this way. This is y equal to e to the power x. And also we have another one that is decreasing function like this, 1 over e to the power x, something like this. This is not a graph anymore. It's supposed to be smooth one. Anyhow, this is the function that is called e to the power minus x. بمعنى آخر, it is 1 over e to the power x. The base is less than 1. It is decreasing. The other one is increasing. الآن يعرفوا من هذه الدالتين دالة جديدة. What is it? It is e to the x. يحدث الفرق بينهم e to the x minus e to the power minus x and divide by 2. هذه الدالة الآن راح يسموها اسم جديد, يعطوها اسم يسموها hyperbolic sine of x. واضح? It is a combination. هذه النقطة الأولى. النقطة الثانية, this is number 1. Number 2, they will take the average of these two functions, e to the x plus e to the power minus x divided by 2. Number 3, they will take that sine hyperbolic and the cosine hyperbolic and they will divide by each other and they will get the formula for what? For hyperbolic tangent. يعني الهايبربوليك tangent راح تصير شنو؟ e to the x minus e to the power minus x divided by e to the x plus e to the power minus x. This is number 3. راح اسمي هذه fundamental functions, the basic functions. The reciprocals now. The reciprocal of sine we know before is cosecant. The reciprocal of hyperbolic sine is hyperbolic cosecant. The hyperbolic cosine inverse will be called secant hyperbolic. The hyperbolic tangent inverse or reciprocal will be called hyperbolic cotangent of x. الآن كيف ننطق الأشياء هذه؟ نقول hyperbolic sine, hyperbolic cosine, hyperbolic tangent. يعني بعض الشباب وبعض حتى المدرسين ينطقها سنش كوش تان. It's not true. لكن if you say it, everybody will understand what you mean. فلما أقول أنا sinh of x, everybody will understand I mean hyperbolic sine of x. لكن mathematically, we need to say hyperbolic sine, not sinh. Hyperbolic cosine, not kush. Hyperbolic tangent, and so on. طيب, أول شغلة نبغى نتعلمها الآن. What is the shape of the basic functions? الثلاث الأساسية اللي هي الساين hyperbolic والcosine hyperbolic والtangent hyperbolic. These are very important functions we have. نيجي للأولى اللي هي hyperbolic sine of x. What is the shape of hyperbolic sine of x? The shape here is given by the red color of this quantity here. I will show you how to find it out. But at the end of the day, nobody will ask you about the graph. يعني the only thing you need to understand it. You need to understand it only. الآن والله شلون نرسم الهايبربوليك ساين of x؟ هذه أول شغلة نبغى نتعلمها. What is the domain of it? What is the range of it؟ لاحظوا الساين هايبربوليك هي معرفة بالطريقة هذه e to the power x minus e to the power minus x divided by 2. طبعا حساب e to the x is not easy, فراح أقربها أنا e أقربها بالثلاثة مثلا 3 to the x minus 3 to the power minus x over 2. Just for simplification. وإلا لو عندك حاسبة سهله جدا، تعمل فقط نقاط وتعوض وتوجد الناتج. لكن الان we need to get an idea how they sketch the graph of this. لاحظوا يا شباب عند الصفر مثلا what is the value of this؟ نعوض بالزيرو. e to the power 0 is 1. e to the power minus 0 is 1. 1 minus 1 is 0. 0 over 2 is 0. يعني النقطة هي نقطة الأصل هنا 0 and 0. طيب عوض بالواحد مثلا، راح نلاحظ عند الواحد تصير تقريبا تصير 3 minus 1/3 divided by 2. واحد المقامات هذه تصير 9 minus 1 اللي هو 8 over 3 over 2 يعني 8 over 6 اللي هي 4 over 3 تقريبا. So يعني if I substitute 1 I will have something greater than 1 little bit here. طيب خلينا نعوض بالاثنين، يطلع 3 to the power 2 minus 3 to the power minus 2 over 2, and the answer will be 9 minus 1 over 9 over 2. If we multiply by 9 that will be 81 minus 1, that is 80 over what? Over 18. That is if you divide by, let us say 2, 40 over 9. 40 over 9 is almost, let us say 4 point something. Okay. Yes. So the answer will be at 2, it is a point here, and so on. So you can graph the function. Let us say it will look like something like this after 0. What about before 0? لاحظ ملاحظة مهمة الآن. What happened if I replace x by minus x for this function؟ راح ألاحظ أن ال f، لاحظوا معي f of x هي بالضبط معطاة بالشكل التالي e to the power x minus e to the power minus x على 2 صحيح؟ طيب لو عوض مكان الاكس بناقص x هنا راح اكتشف شغلتين. اوكي let us substitute. It will be minus x minus e to the power minus x اللي هي x over 2. ونلاحظ ان هذه عبارة عن شنو هو؟ عبارة عن minus بين قوسين e to the x minus e to the power minus x over 2. يعني بمعنى آخر هاي تساوي minus f of x. أحد يستطيع يتذكر لي من 001 الدالة اللي تكون تحقق هذا الشرط شو يسموها؟ f of minus يسموها شنو؟ odd function. أحسنت، يسموها odd function. والodd function شو خاصيتها الهندسية الodd functions؟ It is symmetric with respect to the origin. يعني الشكل اللي هناك راح يجي بالشكل هذا. واضح؟ This is what we have. So this is the way how to graph the hyperbolic sign. طيب سؤال آخر، أحد يستطيع يقول لي what is the domain of this function؟ متى تكون الدالة هذه معرفة؟ What is the domain? The domain of it is the same domain as the exponential function. لأن هي عبارة عن exponential function في النهاية. e to the x is always defined. e to the power minus x always defined. When you take the subtraction, always defined. Difference of two functions. يعني بمعنى آخر the domain will be all real number. طيب what about the range؟ من الشكل الآن أحد يستطيع إقراء لي الرينج الآن حق الدالة؟
Also all
أحسنت. Always it is from minus infinity to infinity. This is an idea how to sketch them. I will not concentrate too much in the graph. لكن المهم عندي انك تحفظ الاشياء الثلاثه هذه. شكل الساين شلون؟ شكل الهايبربوليك كوساين. لاحظوا شكل الهايبربوليك كوساين كانه بارابولا زي كذا. لاحظوا اللي بالاحمر هذه هنا. It's like a parabola. It's not a parabola, but it has the same shape as a parabola, similar to it. طيب من يقرأ لي من الرسم what is the domain, what is the range of the cosine hyperbolic؟ اطلعوا على الدالة. الدومين واضح من الشكل من الدالة نفسها e to the x plus e to the power minus x. I will read it for you. The domain is minus infinity to infinity. تعالوا لي الآن للشكل اللي باللون الأحمر في الجزئية الثانية هذه يقول اقرأوا لي شنو؟ اقرأوا لي شنو الرينج of the function. What is the range of the function؟
From 1 to infinity.
مهمة هذه جدا الواحد يفهمها. ليش؟ لأن تارة في الامتحان بعض الأحيان شو يقولوا لي؟ يقول لي والله which one of the following is not possible مثلا أو possible، ويكتب لي شغلات زي كذا. يقول لي hyperbolic cosine of x مثلا يساوي 1/2. Is this one possible or not possible؟
impossible.
impossible لأن الكوساين دائما أكبر من الواحد. الهايبربوليك cosine always greater than or equal to 1. طيب is this one possible or not possible؟ Is it possible or not possible? Does it have a solution or not?
It's smaller than 1.
Possible.
Pi over e greater than 1 or smaller than 1? That's the question.
Greater than 1.
خلينا نشوف والله الباي هي 3 point something صحيح؟ 3.14 divided by 2 point something. 3 over 2 is it greater than 1? Of course the answer is yes. هي الباي اكبر من الاي، فلما اقسم الباي على الاي لازم يكون اكبر من 1. معناتها هذا شنو ممكن يكون، ف it is possible. ولهذا نقول نحفظ شنو الدومين والرينج على اساس الاشياء اللي زي كذا. طيب what about the tangent? I will come to it inshallah separately. I will show you how to find its domain, how to graph it, how to find the asymptotes, everything. I will come to it in details inshallah in the solution. لكن مبدئيا هذه المعلومات الان اللي قرأناها من الشكل المعطاه. Hyperbolic sine has a domain from minus infinity to infinity. The range is minus infinity to infinity. The hyperbolic cosine has the range 1 to infinity, but domain from minus infinity to infinity. The hyperbolic tangent, the domain is minus infinity to infinity, and the range is minus 1 to 1. الآن نبغى نتعلم شغلات بسيطة. أول شغلة نتعلمها وهذا دائما يجي في الامتحانات how to evaluate these functions. لازم نحفظ التعريف، يعني ما يكتفي والله أعرف hyperbolic sine وأعرف شكلها، لا. I need to know its definition. What is the definition؟ فلما يسألني واحد مثلا what is hyperbolic sine of 2 راح أجاوبه مباشرة أقول له هذا الجواب يساوي، أتذكر التعريف، الهايبربوليك ساين هي عبارة عن e to the x minus، أنا راح أكتبها اليوم لأن أنتم أول مرة تشوفوها، e to the power minus x divided by 2. فمباشرة الجواب شو راح يكون؟ راح يكون e to the power 2 minus e to the power minus 2 divided by 2. Or you can rewrite this one as e squared minus 1 over e squared divided by 2, and you can multiply by e squared, it will be e to the power 4 minus 1 over 2e squared. واضح؟ هذا بالنسبة إلى السؤال الأول hyperbolic sine of 2. More interesting, hyperbolic tangent of length of 3. شلون والله نجاوب السؤال هذا الآن؟ نتذكر what is hyperbolic tangent؟ hyperbolic tangent is hyperbolic sine over hyperbolic cosine. هذا ما يكفي، ما يحتاج يروح اجيب الهايبربوليك ساين واجيب الهايبربوليك كوساين ثم لا. I need to find a formula for hyperbolic tangent. يلا خلونا نتذكر الفورمولا حق الهايبربوليك تانجنت. تساوي hyperbolic tangent of x، شو يساوي هذا؟ هذا يساوي e to the power x minus e to the power minus x. المفروض على 2 هذه الساين، لكن the 2 will cancel with the 2 downstairs. هذه ال e to the x plus e to the power minus x. هذا القانون هو اللي نستخدمه لوين؟ للhyperbolic tangent of x. You can write a note here and use it. So what is the answer for this exercise now? What is the answer for this exercise? I will substitute and I will write the answer. I will first write this formula for you and then I will use it to find the answer. Okay. Remember, I will say recall this, recall that the following. Hyperbolic tangent of x is given by e to the x, the sine, minus e to the power minus x divided by e to the x plus e to the power minus x.
دكتور.
Yes.
ليش رفضت hyperbolic sine over hyperbolic cosine كتان يعني hyperbolic؟
وبعدين كيف بتعوض يعني باللين 3؟ Can you tell me?
صحيح.
Oh, صحيح. Yes, this, yeah, that's what I'm saying here. I didn't reject it. I said we need to evaluate. If we need to evaluate, we need to have a formula to evaluate. And I guess this is the formula to evaluate here. Yes, الآن نعوض الآن. شو يصير tangent of hyperbolic of ln of 3 راح يصير e to the power. لاحظوا يا شباب ما ln of 3 upstairs here. هذه هي x minus e to the power what? Minus ln of 3. صحيح؟ divided by e to the power ln of 3 plus e to the power minus ln of 3. Now we need to use our knowledge in 002 to simplify this. من يقول لي e to the power ln of 3 can be simplified to what? ليش؟ باستخدام القاعدة هذه e to the power ln x equal to what? Equal to x if x is greater than what? If x greater than 0. لأن هذه الدوال ال e وال ln هما inverse of each other, so I can evaluate by cancelling the e with the ln. طيب minus here. أنا راح أكتب شغلة وقولوا لي صح أو خطأ. انا راح اكتب هذه الماينس مع الماينس، هذه راح تصير بلس، والاي مع اللين راح تطير وتصير 3. صح لو خطا؟
خطأ يا
خطا.
دكتور.
طيب شو نسوي يعني؟ شنو اكتب يعني؟
ماينس باور.
ماينس وات؟
1 over 3.
أحسنت. لاحظوا يا شباب، أنت تستخدم القاعدة e to the ln of x equal to x إذا ما في شيء في الخارج هنا. So there is a minus sign we have outside. What should we do with the minus sign? Okay, I will do it this time in 2 steps. I will write it e to the power ln of 3 to the power minus 1. بمعنى آخر I took this one, I put it exponent here. Okay? I took it and I put it as exponent. جميل. نفس الشيء في الأسفل. طبعا هذه 3 plus e to the power ln of 3 to the power minus 1. وبالتالي هذا راح يصير الجواب 3 minus, as your colleague said, it is minus 1 over 3 over 3 plus 1 over 3. I will multiply by 3 up and down. So we have 9 minus 1 over 9 plus 1, and that is equal to 8 over 10, which is actually 4 over 5. So that is the simplest form of the answer, 4 over 5. يلا خلونا نشتغل هذه مع بعض. 1 minus tangent 1 half over 1 plus tangent 1 half. هذا السؤال في الكتاب. This is an exercise from the book. أنا راح أرجع للتانجنت زي ما وعدتكم وأحللها بشكل دقيق إن شاء الله. This is equal to what؟ الآن نتعلم كيف نحسبها فقط. 1 minus tangent 1 half. يلا يا شباب 1 minus tangent 1 half. يلا نخلونا نشتغلها مع بعض. 1 minus، الآن أفتح قوس زي كذا أو كسر زي كذا fraction وأكتب فيها E tangent 1 half. شنو tangent 1 half؟ نصغر شوية. tangent 1 half is E to the power 1 half. المفروض الآن حافظناها. minus E to the power what؟ minus 1 half over E to the power 1 half plus E to the power minus 1 half. All of this divided by 1 plus, everything is the same here, E to the power 1 half minus E to the power minus 1 half all over E to the power 1 half plus E to the power minus 1 half. هذا اللي يسموه في اخذتوه في 001 continued fraction. What should we do to simplify such kind, or what we call complex fraction? I multiply by the LCD. I multiply by the least common denominator. اللي هو في الحالة هذا المقدار هنا LCD. هذا المقدار. I will multiply by this up and down in the numerator as well as in the denominator. يلا لما نضرب الواحد في هذا المقدار شو يعطيني؟ يعطيني E to the power 1 half plus E to the power minus 1 half. ضربت الواحد في هذا المقدار. دائما افضل لما يكون في اشاره ناقص اوضع قوس زي كذا. Okay? If I multiply now, if I multiply the second quantity by E to the power 1 half plus E to the power minus 1 half, it will disappear from the denominator. What is the, surviving quantity? It will be 1 half E to the power 1 half minus E to the power minus 1 half. And observe, I put after the minus sign, I always, to be in a safe side, to put brackets or parentheses, because the minus will be multiplied by both of them. Over. يلا مرة ثانية نضرب الواحد في هذا المقدار اللي في المقام، يصير عندي E to the power 1 half plus E to the power minus 1 half. جميل. طيب plus, should we put parentheses or not? It doesn't make a difference. لكن يلا نوضعها هنا. راح يطلع عندي هنا E to the power 1 half minus E to the power minus 1 half. جميل. الآن what is the final answer؟ بعد التبسيط ها؟ What is the final answer؟ يلا اختصروا لي الأشياء المشتركة. عندي E to the power 1 half minus E to the power 1 half. مع السلامة. I have E to the power minus 1 half minus بيطلع عندي 2 E to the power minus 1 half. You agree with this? In the numerator, this is what we have. طيب what about the denominator? E to the power minus 1 half will disappear and we have twice E to the power 1 half. طيب ممتاز جدا. راح اختصر الآن الاثنين مع الاثنين هذه. طبعا ما نبغى اسس سالبه فراح ننزلها لاسفل تصير 1 over مين يقول لي 1 over what؟ Final answer is 1 over e. لأن e to the power 1 half plus e to the power 1 half is e to the power 1 half plus 1 half, that is 1. So it is e to the power 1. هذا السؤال هو في الكتاب صحيح لكن هذا جاء سابقا في major exam وكان يقول السؤال the quantity here equal to what? And the final answer was 1 over e. Any question before I move to the tangent hyperbolic function and discuss it with you in details? في سؤال على النقاط هذه الآن تعلمنا كيف نحسب الدوال هذه. إذا أحد سألني how to evaluate hyperbolic functions راح أقول له remember the definition. Remember that hyperbolic sign is e to the x minus e to the power minus x over 2. And remember the hyperbolic cosine is e to the x plus e to the power minus x over 2. And remember that the hyperbolic tangent is e to the x minus e to the power minus x divided by e to the power x plus e to the power minus x. طيب قول لي what about the hyperbolic secant? The hyperbolic cosecant, the hyperbolic cotangent. I will tell you, you do not need to remember. The only thing, you take reciprocals. يعني find hyperbolic sine, take the reciprocal, it will give you cosecant. Take the hyperbolic cosine, take the reciprocal, it will give you the hyperbolic secant and so on. جميل. هنا سؤال يقول find all horizontal asymptotes of this function which is called hyperbolic tangent. احنا نعرفها هي الواحد والناقص واحد لكن from where it came I need to explain this. طيب نتذكر من 2.6 how to find horizontal asymptotes. أحد يذكرنا بهذا الشيء؟ how to find horizontal asymptotes.
ساوي البسط بصفر.
لا ما نسوي بسط بصفر. الجواب العام هو يس. أحد قاله يس. we take أيوة. we take the limit as x goes to infinity and we take the limit as x goes to minus infinity. هذا الجواب الصحيح. ف x goes to infinity for the hyperbolic tangent of x. بالتالي أنا مضطر شنو أرجع للتعريف دائما فيصير عندي limit as x goes to infinity. تمام. شو يكون الجواب؟ e to the x minus e to the power minus x over e to the x plus e to the power minus x. أعتقد حلينا السؤال هذا سابقا. Which one is more significant at infinity? e to the x or e to the power minus x? بمعنى آخر هذه الكمية e to the power minus x goes to what?
Zero.
أحسنت zero. You do not say zero, you say zero because you know the answer. So what is the final answer then?
1.
1 because e to the x over e to the x will be 1. So this implies y equal to 1 is horizontal asymptote. طبعا في طريقة أخرى إن نقسم على ال e to the x. إذا قسمنا على ال e to the x راح يطلع عندي الجواب 1 أيضا. كذلك if we take the limit as x goes to minus infinity of this quantity hyperbolic tangent of x. This is equal to what? The limit as x goes to minus infinity. This is e to the x minus e to the power minus x divided by e to the x plus e to the power minus x. جميل جدا. الآن as x goes to minus infinity, which quantity goes to 0?
The second
E to the
one.
power x.
e to the power x.
أحسنت e to the power x. هذه مش the second one. e to the power x لأنه بيصير e to the power minus infinity. فيطلع الجواب شنو في النهاية الآن 0. الآن what is the final answer? Minus because minus 1. أحسنت minus 1 لأن e to the power minus x over e to the power minus x will be cancelled out and you have the answer here y equal to minus 1 is horizontal asymptote. لاحظوا شكل الدالة هذه تقريبا مو بالضبط تقريبا يشبه شنو؟ أحد يتذكر؟ شوفوا شكلها الآن. هذا شكل الدالة. ها هذا يشبه شنو؟
tan inverse.
أيوه tangent inverse. الفرق هنا شنو؟ الاسيمتوتس هناك y equal to pi over 2 minus pi over 2 وهنا الجواب y equal to 1 and y equal to minus 1. ومن هنا استنتجنا ان شنو؟ ان الدومين is equal to minus infinity to infinity and the range is equal to minus 1 to 1. طبعا من الشكل الرينج واضح minus 1 to 1. ليش الدومين minus infinity to infinity؟ خلينا نناقش هذه على حده. ليش الدومين حق الداله التانجنت is minus infinity to infinity؟ راح نشوفها. e to the power x minus e to the power minus x over e to the x plus e to the power minus x. طبعا هي دالة كسرية صحيح؟ الدومين دائما يكون all real number except the zeros of the denominator. لأن دائما الدالة في هذا المثال الآن النيوميريتور always defined الدينومينيتور always defined. يبقى لنا فقط المشكلة لما يكون شنو الدينومينيتور is equal to 0. فالسؤال هل ممكن e to the x plus e to the power minus x يساوي 0؟ من يقول لي ممكن أو لا y؟ Is it possible for this quantity to be 0 and why? Quickly please, we don't have time.
No, because it would never. One of them would never.
No, never equal to 0. Why? Because this quantity always positive and this quantity always positive. If you add two positive answers, you cannot have 0. هذه طريقة ثانية. هذه راح يكونوا متساويين إذا كان e to the x تساوي minus e to the power minus x. هندسيا الآن راح نحل. e to the x هي في الأعلى هنا e to the power x. minus that one minus هذه هي e to the power minus x بالشكل هذا. لما أضربها في ناقص بتصير في الأسفل هنا. and they will never intersect, they will not meet each other. معنى الكلام هذا ان الدومين always from minus infinity to infinity. طيب ممتاز. هذه النقطة الأولى أو الجزء الأول في الدرس اللي هو ما يسمى definition and how to evaluate these functions. إن شاء الله بداية المحاضرة الجاية راح نتكلم عن الهايبربوليك identities. hyperbolic identities. أنا راح اليوم أتكلم عن الأشياء اللي already ناقشناها. مثلا hyperbolic sin minus x يساوي minus sin hyperbolic x. أثبتناها قبل شوية صحيح؟ قلنا f of minus x equal to minus f of x. يعني الhyperbolic sin function is what? Odd or even? It is an odd function. طيب جميل. What about the hyperbolic cosine? Is it odd or even? يلا خلونا نشوفها هذه مع بعض. هايبربوليك كوساين انا اكتفي بهذا المقدار. الهايبربوليك كوساين والتانجنت فقط. لما اجي انا الهايبربوليك كوساين اوف اكس هل هي even or odd؟ شنو اسوي؟ اول لازم ارجع للتعريف e to the power x شنو هو؟ بلس e to the power minus x over 2. سؤالي لكم الان هذه هي ال f of x. What is f of minus x؟ هل يختلف شيء؟ لو عوضنا مكان الاكس بناقص x شو يصير؟ e to the power minus x plus e to the power minus x اللي هو x على 2 اللي هو شنو يعني؟
same
اللي هو f of x. يعني شو نقول عن الهايبربوليك كوساين؟ شو نقول عنها؟
even
نقول عنها even. تمام. What about hyperbolic tangent؟ الآن ما يحتاج hyperbolic tangent of x لو سميناها f of x هي عبارة عن hyperbolic sine of x over hyperbolic cosine of x. جميل. يلا خلونا نعوض عن الاكس بناقص اكس. شو يظهر عندي الان؟ بيظهر عندي hyperbolic sine of minus x divided by hyperbolic cosine of minus x. قلنا الساين odd يعني استطيع اخرج الناقص برا تصير minus hyperbolic sine of x divided by والكوساين even يعني تاكل الناقص ما له معنى يصير عندي cosine hyperbolic of x. الجواب النهائي f of minus x يساوي minus tangent hyperbolic of x يعني بمعنى آخر minus f of x. فنقول عن التانجنت شنو هو؟ odd function. صارت عندي الهايبربوليك ساين odd والهايبربوليك تانجنت odd والهايبربوليك كوساين even. طيب والمعكوس حق هذه الأشياء؟ المعكوس حق الهايبربوليك ساين هايبربوليك كوسيكنت odd. المعكوس حق الهايبربوليك كوساين هايبربوليك سيكنت يعني سيكنت even لأن هي معكوس even function. والhyperbolic cotangent is odd because the hyperbolic tangent is what? Is odd. I think that that's enough for today. لكن فقط على الأقل نعلمكم ليش سموها hyperbolic functions. اطلعوا على الثانية هذه راح نثبتها إن شاء الله المرة الجاية. شو تقول هذه؟ تقول cosine hyperbolic squared minus sine hyperbolic squared equal to 1. راح أثبتها أعتقد هو هذا المثال. شوفوا كوساين سكوير لأنه مهمة جدا الايدنتيتي هذه مثل لما تقولوا ساين تربيع زائد كوساين تربيع يساوي 1. هذه اللي تقابلها في هذه الدوال هايبربوليك كوساين سكوير لكن هنا ماينس هايبربوليك ساين سكوير ايكوال تو 1. انا لو سميت هذه المعادله اكس سكوير ماينس واي سكوير ايكوال تو 1 تعرفوا اسمها هذه اخذتوها في 002
هايبربولا.
هذه معادله هايبربولا. اذا عوضنا عن الاكس يعني عوضنا عن النقطه اكس واي بالهايبربوليك كوساين اوف اكس hyperbolic sine of x شو يطلع تحقق المعادله. هذه النقطه تحقق المعادله. بمعنى اخر هذه الدوال اللي هي hyperbolic cosine hyperbolic sine satisfy the equation of a hyperbola واللي يسموها شنو؟ hyperbolic functions. Not only hyperbolic sine cosine, we will have another one for sine, hyperbolic secant and tangent, and we have hyperbolic cosine. Hyperbolic. We said secant tangent, and we have cotangent and cosecant as we had in trigonometry. طيب الآن هذا ليش سموها هايبربوليك؟ لأنها تحقق معادلة الهايبربولا. طيب ليش سموها هايبربوليك ساين هايبربوليك كوساين؟ إن شاء الله أجاوب هذا السؤال على نهاية المحاضرة القادمة إن شاء الله يوم الأحد. إذا استطعنا يعني نوصل إلى نهاية الدرس راح أتعلق على كلمة هايبربوليك ساين هايبربوليك كوساين. أنتم راح تلاحظوا أن كثير من الايدنتيتيز الموجوده في الهايبربوليك فانكشنز موجوده ايضا في الترانجونومتريك فانكشنز. ممكن اختلاف اشاره او تعبير رياضي، لكن في نوع من التشابه. هل هذا التشابه جاي عشوائيا؟ هل له يعني reference in mathematics؟ ان شاء الله I will explain this in Sunday. So we agree ان شاء الله in Sunday we have our multiple choice quiz as you said. It will be around 25 minutes. And inshallah, another 25 minutes will be just for continuation of this section. If you have questions, I am here. If you don't have, that's it for today. Have a nice weekend. I will see you. في خبر ما أدري صحيح أو لا، يقولوا إنه راح تكون في حظر تجوال